recording. I believe I forgot to introduce this class to a word, and that word is molarity. Okay, and the word molarity means the concentration in moles per liter. Okay, so molarity means concentration in moles per liter. We're on page 59, 59. You will probably, in the question, be given the molarity in the unit capital M. Tell your partner what that capital, how do we read that capital M? Molar, okay? So you will be probably given molarity in the question as molar, but you are going to rewrite it as moles over liter because this you can use as a conversion factor. Yeah, because now you have a unit on the top and you have a unit on the bottom. So now instead of having 4 conversion factors, now we have 5. Okay, now we have 5 conversion factors. And just so that you are aware, on your purple sheet, this is going to be the branch where we go up to the top. Okay, so our molarity takes us from the volume of solution to the moles. Yes, because molarity is measured in moles per liter. So it allows you to convert between moles and volume, which is measured in liters. All right, so that's our new pathway that we can use. All right. All right, so this allows you to convert from liters to moles or from moles to liters. And because we are working in liters, if I give you milliliters, you're going to need to convert that into liters. And how do we do that? You can either do it by using unit conversions and doing the whole thing. Let's say I gave you 250 milliliters. You could say, okay, I would like to cancel my milliliters and find my liters. And you could use your powers of 10, or you could say, I know there are 1,000 milliliters in 1 liter. So that is going to be, we take our number and we divide by 1,000. And if you divide by 1,000, how many places are you moving your decimal place? 3 places. And you're dividing by 3, so you're going to make the number smaller, so you're going to move it 3 places to the left. So that would be boink, boink, boink. There we go. 0.2500 liters. Okay, so first thing you're going to do in any question, you're going to say, do I have molar, capital M? Rewrite it as moles per liter. Do I have milliliters? Rewrite it as liters, convert it into liters. So it's the first 2 things you do. All right, and we have a question here. How many moles of NaCl? How many moles of NaCl are present in, now we have 600 milliliters. What should we do with our milliliters? Rewrite it as liters. And in order to do that, we move our decimal place 1, 2, 3 places to the left. So that's going to be 0.6000 liters. Do I need all of those zeros? To keep track of my sig figs, I do, because that has 4 sig figs in it. If I just write 0.6, it only has 1 sig fig, and I might accidentally round my answer to 1 sig fig. Okay, we also have 1.55 molar. What do we do when we have capital M? We rewrite it as moles per liter, and I would recommend 1.55 moles and then put the whole thing on top of liters, because then it looks like a beautiful conversion factor. Yes? Beautiful conversion factor. So we have two numbers. We have 0.6 liters and we have 1.55 moles per liter, and we want to find the moles of NaCl. Which number should I write first? What is my initial quantity?
Your initial quantity is 600 milliliters.
This one is my initial quantity, and this one is my conversion factor because it has a number on the top and the bottom. So I'm going to write my initial number first, 0.6000 liters, times, and then I'm going to write my conversion factor. What unit has to go on the bottom? The liters, so it cancels. And then we have moles is what we want to find on the top. And we know that we have 1.55 moles per liter. And we do our math on that. And we get 0.6 times 1.55 equals 0.93. And the liters have canceled and we are left with moles. Do we love my answer?
No, moles of what?
What's that? Moles of what?
Just moles.
NaCl. There we go. What about sig figs? Yeah, what about sig figs? 4 sig figs, 3 sig figs. Like it's literally like a 0.93. There's nothing after it. So what should I do to make it 3 sig figs? Add a 0. Okay, so 0.930 moles of NaCl. Would you like to try this next one?
Sure.
Try the next one.
Questions like these, could you also like throw something in there and be like, oh, how many molecules?
Yes, I certainly could, but we're not going to go there yet. But yes, we could be like, how many moles? And then I could be like, well, how many molecules? And so you would go from liters to moles to molecules. Yeah. Yes. So much, I know. We could really call chemistry 11 dimensional analysis 101. Yeah.
At least, well, Mr. McLean did it just give it out. It started with the
Yeah. Yeah. Well, physics doesn't need it as much.
Yeah.
Yeah. Oh, I'm sorry. Okay, so I guess you guys have this there, don't you?
We do. Well, but I'm not looking at it. I'm being faithful.
I would cover it up with a
Yeah.
piece of paper or something. What would you do with your 250 milliliters? Change it to liters. What would it be in liters?
0.25.
0.250. We move our decimal place 3 places to the left. 0.150 capital M. What do we do with that?
Conversion factor.
0.150 moles over liters. Okay, and that's going to give us how many moles? Is equal to, there's our initial quantity, 0.250 liters times 0.150 0.50 moles per liter. And we get 0.25 times 0.15 equals 0.0375. Uh-oh, what did I do? I wrote milliliters. I meant moles. Whoopsie. Moles per liter. Liters cancel out, and we are left with moles of KBr. And I think that's the right sig figs.
Yeah.
So that one's good. Would it be okay if I took my 0.150 moles per liter and maybe in a different question, if I needed to, could I write it as 1 liter for every 0.150 moles? Would that be okay if I needed to do that? Yes. And you'll notice molarity is the one place where the 1 does not go with the mole. Okay, the 1 goes with the liter here. All right, almost everywhere else it goes with the mole, but in molarity, it's going to be a number with the mole and then per 1 liter. All right? Yes.
Actually,
Yes.
if it's 250 milliliters, shouldn't that just be 2 sig figs?
Oh, it should be. Thank you. Yes, that should be 2 sig figs. 250 milliliters without a dot there, that should be 2 sig figs. So that would then become 0.038 moles of KBr. Thank you so much for catching that. Yay, look at you do the sig figs. I know. Yeah. See, they're still the bane of my existence, even though, you know, how many years later? 35 years later. All right, we're going to try another example here. This one is on page 59. What volume? So we're like, I don't know what volume. What volume? What would be we want volume to be in? What unit? Liters, okay? I might say what volume in milliliters, but if I don't say that, you can choose what unit you would like. Okay, this question is on page 60. Page 60, middle of the page. What volume, so how many liters, of 1.25 molar, what should we do with that 1.25 molar? Rewrite it as 1.25 moles per liter. And we want to know how much of that contains 5.0 moles of CaSO4. So there is our initial quantity. There is our conversion factor. Okay, so how many liters is equal to 5.0 moles times, draw your line. I hope most of you are getting in the habit of not writing down numbers right away in your conversion factor. Write down your units first, unless you have no problems, in which case do whatever you want. Yes? But if you're having problems, write down your units first. What should my units be? What goes on the bottom? Moles. Usually it's easiest to figure out what goes on the bottom first because it should be the same as what you started with. What goes on the top? That's going to be what you want to find. So that's going to be liters. Now, we are told we have 1.25 moles per liter. Unless you are really good at doing this in your head, write that down just like that so that you don't accidentally do this. Don't do it, right? It happens all the time. write this down first so that you can look at it and go, oh, what number goes with the mole? That would be 1.25. What number goes with the liter? There's no number, so that would just be a, why are you not erasing? There we go. That would just be a 1. Okay, so 5 divided by 1.25 is 4.
What? For what?
Yeah, for what?
For
Good question. Just for? No, not just for. For what? 4 liters. Okay, we're just left with the liters.
6 pigs.
And also the sig figs. How many should we have? 2. 4.0 liters. Much better. One more example?
Sure.
Okay. How many milliliters this time of 3.0 molar? Every time you see molar, first thing you do, you say, nope, not molar, 3.0 moles over liters. And then we have 0.15 moles of NaOH. And we want how many milliliters? How many milliliters? So we're going to start with 0.15 moles of NaOH. And you're going to cancel moles of NaOH. And you're going to want to find, do we have a conversion factor for moles and milliliters? No, we don't. So we're going to have to go to liters first. So we got liters here. Okay. So we have 3 there and a 1 there.
No.
Are we feeling happy
No.
with what I've shown? No, because it's 3 goes with the mole there, okay? So we've flipped it upside down because we can always flip a conversion factor upside down. 3 moles per 1 liter. And we get 0.15 divided by 3 equals, so you can do this one of 2 ways. You could either stop right here and say that is equal to 0.050 liters. And if you wanted to convert that to milliliters, you would need to move your decimal place 3 places to the
Oh, right.
right. Equals 50 decimal milliliters. Or you could do it all in one row. You could say 0.15 moles times 1 liter per 3.0 moles times, and then we want milliliters. So you would cancel your liters and find milliliters. And we know that there are 1,000 milliliters per liter, and it would give you 50 milliliters. And I don't mind which way you do it as long as you feel comfortable. Okay? Now, I do want to say there are several people in this room who don't know what they're doing on the mole quiz. And I did not see any of those people here this morning or yesterday morning. None of them. Saw none of them. None. I also did not see them working super hard on their work. You know, it's kind of like, I'll do a little chemistry. Which may have gotten you through Science 9 and 10, because Science 9 and 10 are like baby science, yes? But Chemistry 11 is an academic elective, senior elective. You want to pass, you do the work. You make sure you've done the homework. You don't come in and go, oh, I don't know what I'm doing. Why don't you know what you're doing? Because you did not do the homework. Why don't you know what you're doing? Because maybe you did some of the homework, but you didn't really get it and you didn't come ask questions. I don't know how to say this more ways. And I'm sorry, you know what always happens when teachers give a lecture like this? It's always the people who work really hard and like ask questions, whatever. They're like, oh my God, is she talking about me? I'm not talking about you. If you're like, oh, but I do, but I think I do. No, you're fine. You're fine. Okay. You know who you are if you're just sitting around doing nothing. And that's okay. I'm okay with failing you. I'm okay with giving you a 60%. You can get a C minus. What do I care? It's not my report card. I would much rather help you get a B or an A. I would love to do that. That would make me excited. But I am okay if you want to not do anything and get a C. I cannot force you. I cannot hold your hand. I cannot be like, hello, little baby bird. Please open your mouth while I chew your food for you and throw it in your mouth. Can't do it. You're not baby birds anymore. Okay? A year and a half and you'll be out in the real world. Woo. Having to get to jobs on time, having deadlines to meet. So excited. Okay, and with that, your homework is 57:58. Okay, if you have finished that and you want to work ahead, you can do stuff in the molarity, but you can also do that next day. I'm being super kind, okay? Here, I should give you the other questions as well, but I'm not. Because some of you need to go home and review your mole stuff. Some of you. One year before I retire, I want everyone to believe me. No. I'm saying 1 year before I retire, it would be so exciting to have all my students believe me that they could do well if they did the work and came and got help. Because I've had lots of students who have no idea what they're doing, but they did the work and they came and got help and then they did know what they were doing. And it was shocking. It was like, it wasn't shocking actually. It was just like, that's how life should work.
Is there a way to like re-memorize factors? It's kind of like hard because there's so many of them.
Well, you should know the first four.
Yeah.
Now you just added one.
Yeah, but then
Write them down every day when you go home.
write down the theory and factors.
Yep, every day when you go home. Yep.
It's like when you write a test, like it's
Yeah. And so very often what I'll have people do is they'll be like, okay, 1 mole equals 6.02 times 10⁻³. 1 mole equals molar mass in grams. So you're like, particles A equal particles B. Moles A equal moles B. Yeah? And they'll just write that down at the very beginning. So get that anxiety out of them and they're like,
Yeah.
Hi.
yes. Okay.
I would like to is it possible to have some notes?
Of chemistry 12?
Yeah, because I want to know what I'm gonna do.
Yeah. I could sign you out a book if you'd like that. It might be better because my workbooks. There's too many pages. Let me see if I have it here. Ask questions and it's good. They look like they've been eaten by animals because some of them are turning purple. But chemistry is Mr. Wander uses the same book that I did because I was in high school 7. Yes. So I'll get you a book card in a second. Book card. There's also a list of videos. It's through the Open Learning BC.
Thank you.
And they're done by a BC teacher. Let me just see if I can find them here for you. Stop it.